All right, let's start. Now, what I'm going to do today is go into some of the worded questions, trying to model the questions from ways. All right, we're going to start now using the concept of T0. We have been using the concept of T1 quite a bit. So this time, some of the question you've got to think about when you're going to use T0. All right, make sure that you know the difference. So hopefully, by the end of the lesson, you should be able to understand how to use arithmetic and geometric sequences to model real-world problems. Important thing, for X especially, you really need to identify the keywords, how you're going to solve the problems. All right? The keywords will also tell you if the sequence is an arithmetic sequence or geometric sequence. And then you should be able to use the class back to calculate the total amount if required. You don't always have to do that, but sometimes you do have to do that. So if you haven't got a class back, you can grab a class back from it. All right? Now, first, when you talk about arithmetic sequence and geometric sequence, it is actually really useful in solving real-life problems. When you come to, especially this unit 4, when we look at sequence, when we look at finances, the geometric sequence as well as the what we're going to learn next, first order linear sequence, recurrence rule, you will realize that it's really useful in the real world. Now, it is important to choose the correct type of series sequence, actually not series sequences, and know whether you're asked to find the terms or the sum of terms. All right? Now, to check which type of sequence is appropriate, look for keywords such as multiply, divide, percentages. Those are actually generally geometric sequences. And then add and subtract. All right? That's arithmetic sequences. So if a sequence is given, check each pair of terms for a constant difference or a ratio. That is when you don't know whether it's a arithmetic or geometric sequence. All right? Now, let's have a look at example 1. Tony bought a car at the beginning of 2020 at 36,000. The value of the car depreciated by 15%. Now, I'm going to highlight the word after 1 year. After 1 year. Highlight that, please. And continue at this rate every year. After 1 year, in this case, implies that we are going to use not, T0. All right? What happened is, you are thinking about something like, this is the explanation, this is the starting point, start of 2020. All right? So let's say the value is V0. All right? So this would be 36,000. 36,000. And then after 1 year, and which is at the end of 2020 or at the end of 2020 or beginning of 2021, right? So that's 2021, beginning of after 1 year. So that becomes V1. Got it? So you got to think about when you should start with T0 and when you start with T1. So if you've got something like at the start, after a certain time period, you always use not. Alright. But say the next question I'm going to show you is you're going to just start with 1 rather than not. When they're talking about something like a sum of something for the whole year. And then the following year is something else. Alright? So think about it, if there's something that's after 1 year, after a certain time period, you use T0 or V0. Alright? So write a recursive rule for this depreciation. So what I'm going to do is think about depreciate by 15%. If you depreciate by 15%, what is the value after 1 year? How many percent? 0.85 or 85%. Correct? So part A, we know that after 1 year, the value after 1 year is 0.85. Right? So therefore, we need a recursive rule. I use V for the value. Vn plus 1 equals to Vn, sorry, my fault, it should be 0.85 Vn. You know it's geometric. 0.85 Vn. And this time V naught equals to 36,000. Alright? Understand what I did? Louis, the handout is there on that. So this is what we need to do, starting off with V naught rather than V1 this time. Any question before I move on? Yeah?
So if you're given T0 or V0, do you always give that as the, when you do the recursive rule, you always give V0?
Yeah, you use that. Yeah. You use it not. Because you're talking about after 1 year, so you've got initial value. Anything with the initial value, when we, like I said, when we start finance, you put your initial amount in your principal, you will use that as well. Alright, so here, bought the car at 36,000, that is your initial value. After 1 year, it is reduced by 15%, which is 85%. Yeah? Happy with that? Everyone happy with the explanation? Yes? Okay. So once you've got that, you can start to determine the value of Tony's car at the first year. So B is actually 0.85 times 36,000, which is, I've got it worked out. Is 30600. Alright. Our first, second, and third. So you do have to use your calculator. Now let's use the calculator. V naught, V n plus 1 equal to 0.85 Vn. V naught equals 36000. Let's use a calculator. So if you go to sequences, edit clear all. Alright, go to recursive. This time you can see that once you clear everything, you can start using A naught. So An equals to 0.85 An, enter 6,000. And like that. So it's 3600, 30600, 26010, and keep it in 2 decimal places. So the answer is 30600, 26010, 22109.50.
So the type would just be A.
Alright.
A naught. Yeah.
So for anything to do with finance, give it 2 decimal places. Unless the first two is the whole number anyway. Anything with decimal places, give it to 2 decimal places. So I will get rid of that. Let's V1 equals to 30600, V2 equals to 26010. Remember your dollar sign, and V3 equals to 22108.50. 109.50, not 108. Alright, do you all understand what I'm doing? Now, what if you are asked to write this as a general rule? What is going to happen? Watch please. When you are looking at general rule, again it's the same idea. Norm and 1. However, when you've got a general rule, you know that that value is 0.85 times that, correct? After 1. Yeah? So therefore, Vn is 0.8 Vn plus 1. Vn plus 1 equals to 0. Wrong, is the general rule. Vn equals to 36000 times the ratio 0.85 to the power of n. All right. Why did we use that rather than n minus 1? It's because that's our initial value. All right. Initial value after 1 year is 85%. Correct? N has to be 1 rather than 1 minus 1. See what I say? Because we've got initial value. So we don't need the n minus 1 there. We're going to start off with the initial value. We want to find 1 after 1 year. Yeah? Got it? Write that now. Think about it. Because when we have initial value, we don't have that n minus 1. We're just talking about after 1 year, after the certain time period. The word after is so important. Alright? Now, C. Tony will sell his car when the value of the car is below $10,000. Determine the year. Right. Again, I'm going to highlight the word the year. Because you're given the year 2020, you need to work out the year as well. Alright? So, let's go back to your class back. So, $10,000. Alright. T7 equals to 11541.78. T8 equals to 9809.666. Alright? So, what you need to do is, when you answer this sort of question, write down T7 equals to 11541.78 and T8 equals to 9809.66. So you know that it's after 8th year. Correct? In the 8th year. Do you all agree with me? Yeah? Because it's 8. I started with 0. I made this easy. Starting with 0, so you know 1. After 1 is 2021, 2022. Alright? Now, in the exam, they will not be so kind. They will use something different. I do this because I want to illustrate the idea of not. I use this because I want to illustrate the idea of not. Therefore, you can see that Tony will sell his car. In 2028. Alright? Answer the question. Highlight, when you look at question like this, highlight it. I would do it this way. For example, I'll write down, highlight this, and write down V naught. Alright? You can use D naught, it doesn't matter. I use V naught because of value. Alright, can you read the second question, please? Alright, I'm going to change part B. Determine the total amount. Oh yeah, we can because we can use this and use the sum. Fundraise over 2 years. Read this question. Now here, it says that in the first year, he raised 2500 for the club. Is there any word such as after? It's during that year. So that's the total for the whole year. So you start off with 1 rather than 0. Okay, you are not going from 1 and then the second one and the third one and the fourth one. From 0 to 1 to 2 to 3. So this one is actually just 1. First year is 1. Second year is 20,000. Third year is 16,000. Alright, and this continues a similar pattern. How much does Yannick raise in the first year? Now, what you need to do is to work out whether this is arithmetic or geometric sequence. Which one do you think it is? Arithmetic or geometric? Geometric? Sorry? Beg your pardon? Is it arithmetic? Let's write down. Alright, if you're not sure, always write down. In the sequence format. So it's 25000 and then 20000 and then 160. All right. Now, looking at this, do you think it's arithmetic? No. So you can see that it is actually geometric. How do you work out the common ratio? Use that. You need to check this one. You really need to check. Divide by 25000, which is equals to, I would say, 0.8. Same with that. Alright? You must check. You must check. You were not told whether it's arithmetic or whether it's geometric. You must check. Alright? So you know R now. So you raise that much money, and second year so much. How much does Yannick raise in his 5th year? So let's write out either the arithmetic or the geometric, the recursive rule or the general rule. So if I want to use general rule in this case, I can use, let's say, fundraising. I'll use F, and I'll use, doesn't matter, 0.8 Fn. F1 equals to 25,000. You can either use your sequence or you can use your calculator, just work out from 3rd year times 0.8 and then times 0.8. But I want to show you part B. How about fundraised over 12 years? Right, we need to be able to use the sum. Writing this down. So Fn plus 1 equals to 0.8 Fn, F1 equals to 25000. Alright,
this one?
use your calculator. Now,
Yeah.
in your calculator,
Continue.
again for any question, starting a new question, clear all place. Always do that.
Because isn't it explicit?
Alright, so this one
Geometric.
is,
I mean, not.
I'm going to
geometric,
use
isn't it?
A1 rather than A
It's not arithmetic.
0, so it's 0.8 times AN, and that A1 is 25,000. Alright, Ted. Now, question 2 requires the sum over 12 years. Now, go to this button here. This diamond, tap on that, and the sigma display, which is the sum. Sigma display, tap on. It's always good to read forward. Read the whole question first rather than answering just one question, so that you know what is required. So that's one step there, and tap on that. See, straight away you've got the sum as well as the amount. Alright? Yeah? So you know the 5th year, tap on that, it's a whole number. 5th year, F5 is 10240. Alright, let's keep going down. Now, it gives you in E. So what you need to do is tap after in the 12 years. So he's raised sum to, or actually you can use S. S5, that's sum. Let's use that. Or you can use sum to 12 years is 116,410.07. Alright? Do you understand what I do there? How I get the sum out? So, here, F5 equals to 10240. Alright? and then be after 12 years. Determine the total amount Yannick has fundraised over 12 years. All right, after 12 years,
So you can do
the
the
sum,
arithmetic way of
the total amount.
explicit rule. I'll do the recursive.
As
the
raised
repeated. But why not the explicit rule?
is
Doesn't matter.
116,410.67. All right, here the word total amount just tells you it is the sum. So what I've done here is I have highlighted important information. All right, you know that there's no after, so it's during the first year. Any question before I move on to the next example? I'm taking my time to explain these examples because this will, you will be getting this sort of really worded question in the exam or the test. All right, next. At a famous ski resort, the temperature is displayed on a projector and they update this temperature every year. 1 hour after opening the ski lift, the temperature was displayed at 3 degrees. The temperature steadily declined and got colder as the day went on, dropping 0.5 every hour. How many hours after opening the ski lift did the temperature reach 0? Now here, 1 hour after the opening, all right, the temperature display is 3. Do you use T0 or T1? Sorry? Read the question again. 1 hour after
T1.
T1. Because it's already after, so this is T1. Got it? Yeah? Yeah? Do you understand what I'm doing? This is T1 because it's already 1 hour after.
Yeah.
Now, this one dropping 0.5 hours every hour, at 0.5 degrees every hour, is it arithmetic or geometry? Arithmetic because it's constant, 0.5 degrees every hour. Yeah? So therefore, I can write down T n plus 1 equals to T n minus 0.5 and T1 equals to 3. All right? Now, use your calculator or you can just work out when does T whatever achieve 0 degrees. Yeah? This is showing you how to interpret the question. I'm not actually going to do the whole solution for you. You can do the solution. I think if I got it right, is n equals to 7 after 7 hours. Or you can actually use the general rule if you want to, but it really doesn't matter. If you want to use the general rule, is Tn equals to 3 plus n minus 1 d, which is 0.5. All right, so you know Tn equals to 0. We don't know what n is. 0 equals to 3 plus 0.5 n minus 0.5. All right, so sorry, it's the difference is minus my fault.
6.
So remember, if you do something like this, if you do a general rule, it should be negative. So therefore, this is
You got 6 to plus 7.
plus 0.5 minus. So 3.5, 0 equals 3.5
3.
minus 0.5 n.
The question is
So
doing
therefore,
now.
n equals to 7 hours, after 7 hours.
What?
All right?
It's
So after 7 hours, after the opening
get it
ski
wrong.
lift, after the ski lift open, the temperature reaches 0 degrees. So write down after 7 hours.
when did I get it wrong?
All right, next example.
These doesn't.
Can you read and highlight the information you think is important? I want you to highlight the information that's important. All right, I will highlight it and I'll show you in a few minutes. 3 seconds. You do it first. first bit, I've highlighted two things. One is decreasing at the rate of 1.3% every year. And the other one is at the start of 2007, the population is 11000. See the two things I use. It's good idea if you got a highlighter or a couple of highlighters in the exam, highlight the things that are related. So I know that I'm relating decreasing rate 1.3% every year and the start. So if it is the start of 2007, it will be naught, correct? Let's say this is P naught. All right, decreasing the rate of 1.3% every year. All right, now, question A, what will be the Quokkas population at the end of 2020 in Rottnest? Answer to the nearest whole number. No decimal, this will be definitely integer. In what year do they estimate the Quokka population to fall below 8,000? All right, so we know we need to answer question number one is the end of 2020. Now, if you're not sure, you can always use your fingers to count. So at the end of 2027 is year one, right? At the end of 2007 is year one, 2008, 2009, 2020. So it's 4 years. It's fine. In the exam, if you're not sure, use your fingers. What are your fingers for? There for you to count. All right? It helps. Anything that helps you to work out what is years, do that. All right? So if it is decreasing at a rate of 1.3% every year, what is the ratio?
0.9.
What's the ratio?
I just said
And this one is take at
Ratio.
the end because it's got the
All right.
original year.
Right. To work it out. R equals to
Not
1
really.
minus
because that's your starting.
0.013.
When is
That's
it?
T0.
So
it's
it's
when's it ends at
0.987.
1 when it's not?
All right.
It starts with T1.
And minus
1.3%. So R is
Because
0.987.
technically that's
So
0
now
times,
write
so you
down
have to
the
times it.
recurrence relation. Pn plus 1 equals to 0.987. Pn. P naught equals to 11000. All right. Do you understand how I do it? How I interpret the question? This is one of the most important things for apps, is really able to decipher, highlight the information, and then answer it, especially this part with sequences and sequences. All right. So therefore, if you use your calculator, 2020 would be P4. Let's look up here. Alright, use your calculator, clear everything. Now you don't need the sum of the display. Don't worry about it, just turn it off. The reason why you want to turn it off is if you have two things going on at the same time, the calculator is a little bit slower. Clear all. So this is 0.987. Oops, I want A naught, that's correct. AN, and then that is 11000. Type on that and click on that. So for year 4 is P4 is 10439.05. So it's approximately 10439. Alright, that is your that would be your answer. And then it wants to fall below 8,000, keep going.
Didn't want to pass.
8,000, is it 8,000? So P 24 equals to
Yeah, what will the population be at the end of
8035.34.
2022?
P25 equals to 7930.88.
P14.
So this is how you would answer the question. P4 equals to 10439.05.
20. Start at 20.
So the
Well, it's gonna be
population
13. No, it should be 13 because 2021 hasn't happened yet.
in 2020 will
You made that.
be
I think
uh,
we set it this way.
10439. Alright? Make sure it's whole number, yeah?
No, because you're at the start of 2007, so after 1
Oh, it is 14 years, sorry, my fault. Not 4. I'll count it to 2010, that's all 14 years, my fault. Yeah, it is, sorry, it's 14 years. So 2020 is, sorry?
9,100.
After 1 year.
Is it 9 now? I don't know.
Start is
Let me have a
2007,
quick look.
you'll be
Sorry, it's my
starting
fault, it's 14.
9, 10. Start with 10.
9278.
Isn't it 3 or 13?
Point three,
I think it's
9279.
Wait,
Sorry?
And maybe
So-
you said at the end.
should it be 13? Because like,
Yeah, it's
Oh, no,
after.
it's the end.
So
Right.
think about it.
At the
End of
end of
2007 is 1.
So
End
it's,
of 20
yeah, but
count.
still, like,
2007 is 1.
yeah.
End of 2007, 2008, 2009 is end of 2020.
Oh.
Alright, it's 14 years.
But after 1 year from
After
start
1
of-
year, let's have a
Alright,
read
let's
of the
do
question again. Alright?
It is saying it was at the end of 2022.
It is 14 because start here. Let's write down 2007 start. Alright, this is not.
Yep.
And then 2007, that's 1, end of 2007. End of 2008
Oh.
is 2. 2009 is 3. 2010 is 4.
Yeah.
2011, 2012, 13, 14, 15, 16, 17, 18, 19, 20, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Alright? Because that is at the end. So assume that the start of 2007 is the end of 2008. You can say that as
Okay.
2006. Alright?
Yeah, okay.
Got it?
Yeah.
Yeah.
Okay.
Yeah, this is the bit that is tricky, so you need to know what to do. From there, you should be able to work out what is P25. So part B is 2020. 2020 is, it should be P14, which is 9279.30. Yeah,
Right, just use the explicit rule.
sorry?
If you don't, if you use the
Yeah, because it's a
explicit
start
rule
and the
for
end.
this shit, then-
Because this is start, this is the end. So 2007 start is 0. It could be considered as the end of 2006. Alright? So if you want, think about
Okay.
the start of 2007 is the end of 2006. You're going from the end of 2006 to 2007. Yeah? Clear enough?
Yeah.
So it's always good to write something down. If you're not sure, take the few seconds to do it. Alright? Yes, can I finish everything today? Yeah. So it will be 9280. Alright? So the next one is what year to date estimate. So part B, we did P
You got it wrong.
24 is 8035.34.
No, you can't run. No.
P25 is 7930.88. So now the start of
No, you did T14.
2007 is 0. So 2007 is 1.
Two
Alright.
13.
How do you go to P25? You can keep going, you can keep writing this. It really doesn't matter. This is your working.
Yeah, he did
15,
T13.
16, 17, 18, 19, 20,
He did T13,
21,
not
22,
T14.
23, 24,
Oh, you
25.
meant to do that?
Alright, so it's 2020,
13.
21, 22, 23,
No.
24, 25,
That's what we just
26,
talked about.
27, 28,
Is it
29, 30, 31. Alright,
What's the end?
you can do that, that's fine.
You know how you're saying
It's
that's the
pretty
end of
much
96.
how you work it out. You can write, if you're not sure, just write it out this way. So it is in the year 2031. the population
Break the calculator. 7, 8. Oh shit.
will fall below
T30.
8,000.
The previous year is
Alright.
the same as the start of the next year.
Now you must practice questions like this because
But it's the end.
it's going to be that sort of question. They will make sure that you answer a question like this. All right. Next, I'm going to try to finish 2 more questions. All right, Fiona is training to run a marathon. She runs 8 kilometers per day. In the first week of training, she runs 5 kilometers per day. In the second week, she runs 8 kilometers per day. And in the third week, she runs 10 kilometers per day and so on. All right? How many kilometers will she run in 8 weeks of training? So I'm going to highlight first week is 5K. Second week, 8K. Third week, 11K. All right? Now, write this down. This is 5, 8, and 11. So if this geometry or arithmetic,
Arithmetic.
you know it's 3K every day, every week. So T n plus 1 Tn plus 1 equals to Tn plus 3. Alright? T1 equals to 5. How many kilometers will run in 8 weeks? So you use your calculator, use your class bag. Alright? Assuming that this pattern continues for 16 weeks in total, determine the total distance. Remember, use the display of the sum. Alright, part B, I'll show you how to use your class bag. Okay. So Tn plus 1 equals to Tn plus 3. T1 equals to 5. Alright, let's use the class bag. Clear everything? Clear everything. Now, because it's talking about each week, so you need to go to 1. Here, An plus 3. Start off with 5. That one there. Oh, actually, you need to show the sum as well. Show the sum. Alright, so you can see that, what was the question? T8 week. So you need to know T8. T8 equals to 26. And then right at the end, after 16 weeks in total, sum after 16 weeks is 440 kilometers. Alright, use your class bag. Always use your class bag to work out the sum as well as the value in week 8. Any question here? Alright, if not, let's go to the last question. Last one. A ball, this is a difficult one. This is probably one of the most difficult one that you will get. A ball is dropped from a height of 20 meters and it rebounds to a height of 16 meters. Every bound is continues to rebound in the same proportion of its previous height. Now, same proportion, so you need to work up your R. Alright? You start from 20, you start from 6. Now, this one, you've got to be careful whether that is a naught or whether it is 1. Alright? Draw a diagram to represent this situation. Let me show you what I mean. So from here, the ball, there's a floor, dropped. 20, down, and then up. 16. Down here, and then up again. And down here, and then up again. Alright, and then down. Now, here, the height there is actually not. I will say that this is H1 because this is the first bound. After the first bound, it go up to H1. Alright, T0 bound, the first bound, it go up to H1. Got it? So this will be H1, this will be H2, this will be H3. Happy with that? Understand what I'm trying to get at? So you need to think about what it is related to. This is related to the bounds. Alright? So determine R decimal, the proportion of the previous height reached after each bound. So part B, R equals to 16 divided by 20, which is 0.8. Alright, in decimal. Write the rule for the height for all ball Hn after n bounces. Now, a rule means general rule. Alright? So, part C, you know Hn is therefore 20 times R, which is 0.8, to the power of n. So after the first bound, it's 20 times 0.8, correct? So n equals to 1. Alright, not n minus 1. Everybody okay with that? Yeah? Alright, and then you can find the height after reach after the 10 bounds. Alright, which is H10. 20 times 0.8 to the power of 10.
Oh, he's 20.
And you need to use your calculator
He's
to work
16,
out.
so I'll have to use it and take one.
Alright. Now I'm going to stop here. What I've done is I've shown you 5 different examples. Think about how you could work out the problem as arithmetic or geometric. Think about when you use log or when you use 1. Alright? Read the question carefully. If you got an initial value, after means you got 0, start off with not, and then you got 1. Alright? Happy? Yes? Alright, I'm going to stop here. Yes?